Hello friends, welcome to Truth of Physics. In this video, I will derive the expression this, the commutation relation this. This is a well-known commutation relation in quantum mechanics. Here L is our orbital angular momentum. Orbital angular momentum. Now in this video, I am not going to discuss the concepts of what L is. The concepts I will discuss and derive only this relation in this video. So we know that L means the orbital angular momentum. So in classical mechanics, we know that L is what? The angular momentum in classical mechanics, L P means R cross P, where R is the position vector. So I'm going to just discuss it in detail. I will discuss step by step. Okay. So R means X, Y, and Z, and this is Px, Py, and Pz. So this will be equals to so in general, this is what? This is the ith component. That means the x component of L. L is what? A vector quantity. So L can be dissolved with Lx I cap plus Ly z cap and Lz k cap. So this is what? This is nothing but our Lx component. This is Ly and this is Lz. So let us come to the derivation part. So okay. Now Lx Ly means what? Let us understand it now. So I have to write here Lx Ly in commutation bracket. This means this is called the commutation bracket. Suppose we have a comma bracket, that means this will be equals to AB minus BA. This is the meaning of the commutation. Here is a comma. Now let us write the Lx and Ly. Y P Z minus Z P Y, comma. This I am just taking this minus inside. That means this will be Z P X minus X P Z. Now we can split this. How? If we have this A plus, suppose A plus B comma C, this type of thing, then we can write A comma C. This is a property, okay, commutation relation, the property of commutation relation. So for simplicity, I am just giving example, and then I am just doing a step by step derivation. Otherwise you will be very much confused okay, about this thing. So I will do this thing here for this relation. So what will be that? This thing, this total thing into this means Y Pz minus Z Py Z Px minus and this and this. So this will be Y Pz minus Z Py X Pz. Okay. Now here is the commutation relation, commutation bracket. Here is the commutation bracket. Now okay, now I can write here that okay, let us understand another example. Okay, now I can again split it like in this way. I can split this. So what will be that? This into this means Y Pz comma Z, here is comma, here is comma, Z Px, okay, minus Y, sorry, Z Py comma Z Px, sorry, this, and like similarly for this. Now for the sake of simplicity, I am just denoting four things. Why I am denoting that? Because if we want to calculate this, we have to split it again. Now what is the how can I split this? Now there is another relation like AB. If we have AB comma C, then I can write here A fixed into B in the commutation relation plus A is inside the commutation bracket and B is outside. It is like the similar way, the derivative of ddt of suppose mv, the momentum. So the actual process is like this: m fixed dv dt. Like in quantum mechanics, you have to, when you do or when you conduct with the operators, then you have to strictly follow this actual rule. And in classical mechanics, this actually becomes means if you do in any way, then that do not matter in very much. But in quantum mechanics, this thing matters. What is the thing? I am just stating the order matters, because in quantum mechanics these are operators. We are conducting with the operators, so the order matters always, because these are actually matrices. Okay, so the actual process of this, uh, the derivative of m with respect to t into v is constant, like this. Okay, so we will do the same thing here. Like here we have to do this. So y, let us denote it, this total term a, this total term b. So a minus b, this total term with c, a minus b minus c minus b. There's a plus sign here, so I have to write here plus. Okay, now let us consider first a. What will be a? Okay, now, okay, now a is equals to this. So if we do this here step by step, first we will break this. Then what happens? Then y is fixed and p will be inside the commutation bracket. So pz comma zpx, fine, plus y is inside comma zpx, and the pz is outside, right? In this way, this is only third brackets. Okay, this is only third brackets. Now, okay, now in the next step what we can do, now we have to split here. So this is pz. So this will be like z is fixed, so z in commutation bracket pz, z is fixed, and pz comma px. So I am now doing this first, plus z pz comma z px is outside. Okay, similarly for this will look like this, the total thing. Okay, now what we'll have to do now, this, what will be this, the value of this. So let us understand that pz comma px means pz, this will be equals to the commutation. When you remove the commutation bracket, then it will comes out to be pz px minus px pz. Now you can easily understand that these two things are same, so this will just comes out to be 0. How these two is equals to same? Now px, what is px? Px is equals to minus ih del over del x. So if we have like this, pz into px, I'm just ignoring this term, I'm just dealing with this derivative. Then what will get, or more simply, if I do here the psi, this of psi, then what will be that? That means the del del z into, in bracket, del x of psi, right? So I can just interchange these two. So that means the del x of del z of psi. This can be interchanged using the rules of partial derivative. So from here you can easily understand that this is true. This relation will be true. Then I can just ignore this term, or this term will just be equals to 0. Now coming to this term, this is what, this term is what actually this term, there is a you can also prove that, but I'm not going to do that proof here. So this will be equals to minus I h cut, this will be just minus I h cut, the value of this commutation relation, or like this commutation relation. So px comma if there is px comma x or py comma y, then that will be equals to minus ih hat. So there, this is a very important relation. Now coming to this, what will be this? So if we break this, or we can, if we want to find this, so this will be like this, because if we break this, then that will be wait, y is x minus pxy. Right, now what will be this? Y px is equals to y del del x. Right, now there is a psi, suppose, so there is a psi. So I can, as this is a derivative, as this is a partial derivative with respect to x, that means y can be treated as a constant here. Y is treated as a constant here, so y can be taken inside this, or I can write it simply here that this is equals to our del x of y into psi. Okay, so and similarly, what will be this? This will be equals to, if you want to do this here, so this will be our del x into y and psi. So just to think about this, these and these are just the same thing. That means this will just give us 0. That means this will also turn out to be 0. And this yz, the computation of yz will be what? Y comma yz minus zy. So these two are will be just same, so this will be also equals to 0. So this term will also vanish, so we will left with only one term, and that is only this term. That means only this will survive. That means there is a px with this px, and there is a y, so this is y. So this will be equals to our a. So I am just boxing it because this is very much important. Now our actual motive was to find the commutation bracket of Lx comma Ly. Now to find that, we have to find A, B, C and D, the value of these things. Now we have found the value of A, right? Now is this necessary to find the value of B, C and D like this way? No, there is a short trick or a simple analogy. What is the analogy? Let us understand this. So just take a look at this thing here. Just take an analogy. Okay, here y, first start with y. So y y, okay, 1 minute. Y, okay, yes, y is commuted with, y is connected with z. Okay, then first y, connect y with z. Here it is, here this is the term, y is connected, sorry, not this, y is connected with z, right? This term, y is connected with z. Now y is connected with px, y is connected with px, this term, right? Similarly, now come to pz. Pz is connected with z, this term, pz is connected with z, and at last pz is connected with px. Pz is connected with px, this term. So these are the 4 terms. So we have to just make the commutations, make the combinations of these things. Okay, so you will understand that this is actually happening here. If we break this with the rules, then we'll come at last this thing. So this is the actual thing. So now we'll do the same thing here. So we'll do the same thing for this thing also. So z, first z is connected with this, so what will be that? Z, I'm just taking this roughly because I'm not writing here the additional terms like these things and these things and the additional terms. So z and z, there is a commutation of z and z, plus there is the second term will be what? Z comma px. Similarly, I'm doing this first. Now py comma z, right? So I'm just changing the color to make it clear. Py comma z and py comma z, and there is the last term, which is what? Py comma px, py comma px. Okay, now it is very much clear that this term will be what? This term will be 0 in a similar pattern of what we have followed previously. This will be what? This will be also equals to 0. This will be what? This will be also equals to 0, and this is also equals to 0, because these two are same. So this total will be equals to 0. So this term total will be equals to just 0. Similarly, come to here, y, first y is this. So wait a minute, yeah, y x plus y is connected with pz okay, plus pz and px and pz and py, comma pz, the commutation of this. So this will be equals to 0 because these two are same. This will be also equals to 0, this will be also equals to 0, this is also equals to 0. So the total is equals to 0 again. So this will also be equals to 0. Now come to this term. Okay, now wait, okay, yeah, now this term z. So what will be that? Z comma x, the commutation of this, plus z comma pz plus py comma x and py comma okay p. So all the terms will be equals to 0. This will be 0, this will be 0, this will be 0, and the last term, that is this will not be equals to 0. This will be IH cut. Why? Because we know that pz comma z is equals to minus IH cut. So the reverse thing will be this. Okay, so this is actually, so what was that? So this term is equals to IH cut. So what was this term? This term was our d, right? This term was our d. So d is equals to IH cut, and not only this will not be equals to IH cut, because I have just do this rough calculation. So the actual, what will the actual value of d? Let us calculate this. Okay, the actual value of d. So what was our d? This, right? So I am just removing these things. So we can split it like this, right? Just breaking this thing, and now we'll break this and this thing separately. So what will be that? This will just be equals to x into py. So you can easily understand that this term will also vanish and this term will also vanish. Now next, this is finished. Now this total term, what will be this? I am writing this in the second line. Now z comma x will be outside. This term is equals to what? IH cut, and this term will vanish. So at last we will get IH cut x and py. So this is the value of d. Okay, so this is our value of d. So I am just boxing it. Now we have got the value of total thing, that is a minus b, this thing, the total thing, a minus b minus c plus d. So what will be the value? Just a and d will survive. So I can write the actual value of this operator of this thing, the commutation bracket of lx comma ly. So finally equals to a plus d, which is equals to this thing, minus IH cut, this thing, minus IH cut y px plus this thing, plus IH cut x and py. So if we common this thing, we common this, so we'll get, so this is equals to IH cut, and this thing is LZ. We have discussed this here. This was our x, this was what? This was LZ, means x py minus y px, x py minus y px. So this is LZ. So the commutation bracket of Lx comma Ly is equals to I h cut LZ. So this is the relation. So this is proved now. So share this video with your friends, and if you have any doubt then comment me below. So take care of yourself. Thanks for watching.